I want you to imagine, just for a second, that you could strap this magical, infinitely zooming microscope directly to your eye.
Oh, wow, okay.
Yeah, and you aren't just using it to look at, you know, a static petri dish in some sterile lab. You are taking this completely impossible device on a walk through a crowded, everyday place.
Right, like a busy park or something.
Exactly, like a bustling city park on a Tuesday afternoon.
Yeah.
And the question is, what would you actually see?
Well, the sources we are diving into today present precisely this scenario, framing it as this mind-bending, philosophical, and, well, scientific thought experiment.
Which is just wild to think about.
It really is. And the whole mission of this deep dive is to take you, the listener, progressively deeper into the very fabric of reality.
So we're zooming way in.
Way in. We're starting from the perspective of a tiny insect, and then we push further down into the living biological machinery of a leaf.
Right.
And finally, we cross that ultimate boundary down to the quantum level of a single atom.
And the fascinating part of this journey, I mean, the thing that really gets me is that the physical rules you rely on every single day are just, they're about to completely break.
Oh, absolutely. They shatter.
Yeah, because as you turn the zoom dial on this microscope, the fundamental laws of our three-dimensional world, like how you navigate space, how you experience the passage of time.
Even the basic behavior of light itself.
Yes, all of it completely warps. It's totally unrecognizable.
Because we are just so entirely conditioned by our human scale reality, I mean, we assume the physics governing our morning commute just apply universally everywhere.
Right, which they don't.
They absolutely do not. So let's just initiate that first zoom. We are scaling your perception down to the micro level, basically dropping you right into the grass and the dirt.
Okay, so down at this scale, the humans walking past you in that park are no longer recognizable as people.
No, not at all.
You are suddenly navigating this terrifying world of colossal titans. I mean, the legs of a passing jogger. There are these giant, moving, fleshy pillars that completely block out the sun.
It sounds like a horror movie.
It kind of is. And if you look at the clothes they're wearing, like a simple cotton t-shirt or denim jeans, they don't look like solid fabric anymore.
Right. The texture completely changes.
Yeah, they look like thick braided ropes, just roughly interwoven to form these massive shifting walls.
And the topography of the human body becomes entirely alien, too.
Yeah.
Like if you catch a glimpse of human skin at this magnification, you don't see a smooth surface.
Oh, that's definitely not smooth.
No. You are looking at a vast, rugged mountain range. You see these gaping, cavernous craters.
Which are literally just pores, right?
Exactly, just normal pores.
Yep.
And rising out of those craters are towering, translucent tree trunks.
The hairs.
Yeah, the hairs. So any recognizable human context, any facial expression or sense of identity is just completely stripped away by the sheer scale of it all.
It totally transforms the mundane into something monstrous. But the source material also highlights these incredibly vivid details about the micro world we usually just, swat away without thinking.
Like the insects.
Exactly. A bee flying past you isn't this cute little yellow bug anymore. Down here, a bee is essentially a heavily armored military helicopter.
That's a great image.
Right. You can see its golden hairs protruding like these thick defensive spikes. And its wings aren't just a blur anymore.
Because your perception of them has changed.
Yeah, you can physically trace the massive pulsing veins pumping fluid through the wings as they violently beat against the air.
And down on the ground, the ants are basically treating the humans like natural disasters.
Oh, totally, like apocalyptic meteors crashing down.
Exactly. They're dodging those giant human shoes falling from the sky. And watching them, you realize they aren't just wandering aimlessly around the dirt.
Right, they have a whole system.
They do. You can see them actively strategizing, communicating through chemical signals and coordinating to carry chunks of food that, well, relative to your current tiny size, are basically the size of boulders.
That is just wild. And even the atmosphere itself is completely transformed. Like you look up and the pollen grains and dust motes aren't just invisible annoyances making you sneeze.
They look totally different.
Yeah, because of how light refracts at this specific scale, they look like glowing meteorites just suspended and drifting lazily through the air.
It's beautiful, but also kind of terrifying.
Definitely. But, the detail from the sources that fundamentally shifts the paradigm here is what happens to physical space itself.
Yes. The z-axis.
Right, specifically depth, the z-axis.
The space-time shift at this micro level is just profound. In our standard human scale, leaf lying on the sidewalk is, for all practical purposes, it's a flat, two-dimensional object.
Right, it's basically paper.
Exactly. But at this micro scale, the z-axis, the depth of the world, becomes monstrously exaggerated. That quote-unquote flat leaf suddenly has deep, perilous valleys and towering, jagged mountains.
The surface complexity is just staggering.
It really is.
To put that spatial expansion into perspective for you guys listening, think about the anatomy of an ant. From our view up here, an ant is just a speck.
A tiny little dot.
But down there, the distance between an ant's front pincers and its back legs, it feels like miles of rough terrain. It's like if you were walking across a perfectly flat piece of paper and suddenly that paper just violently unfolded into the Grand Canyon.
Yeah, that's the perfect analogy for it.
Right. So if you tried to walk across a simple suburban lawn at this scale, it wouldn't take you a few seconds. The terrain is so incredibly vast and rugged, it would literally take you weeks of grueling physical travel just across the yard.
Which brings up a really fascinating point about time.
Yes, because this leads directly to a massive logical problem, right? If my framework for speed and distance is completely broken because space has expanded so drastically.
Getting from point A to point B takes an eternity.
Exactly. So that has to fundamentally alter the perception of time, right? Like it has to.
It absolutely does. And physics backs this up by explicitly linking space and time together. Because the spatial terrain has become so incredibly complex and vast, time drastically slows down for you, the observer.
Okay, so time slows down.
Yeah. A single human second is no longer a fleeting, singular moment. That 1 second expands and stretches out to contain millions of micro-events.
Wow. Okay, so that perfectly explains the helicopter bee.
Exactly, yeah.
Because, a bee beats its wings roughly 200 times a second. To a human, that's just a hum and a blur.
Right, you can't even see it moving.
But the source notes that down here, with time stretching out to accommodate that massive spatial depth, that frantic bee actually looks like a giant, majestic bird, just slowly sweeping its heavy wings up and down.
It's entirely cinematic, and, a falling drop of dew provides another brilliant example of this.
Oh, I love this part.
In our macro world, a dewdrop is just a quick, insignificant plop onto a blade of grass. But in this scaled-down reality, because you are processing so many micro-events within that single second,
it looks completely different.
It does. That falling dewdrop looks like a massive, crystalline glass palace collapsing in extreme slow motion.
That is such a crazy image.
You can literally track every single ripple on its surface and watch how the light distorts inside it as it slowly descends.
Okay, so we have monstrous depth and time is moving like molasses. So let's push the boundaries again. We are upgrading the magnification and zooming past the surface of that deeply cavernous leaf right into its internal cellular structure.
And this is where things get really weird.
Extremely weird. Because the sources point out a jarring shift right here. That massive z-axis we just spent all this time exploring, it completely vanishes.
Yeah, we are transitioning into a genuinely two-dimensional world now. Once you breach the surface and enter the actual cellular architecture of the leaf, the concept of depth basically ceases to exist.
You just lose it entirely.
You lose any sense of in front of or behind.
Right.
The internal structure becomes this flat, perfectly two-dimensional mosaic.
So what does it actually look like?
Well, visually, the sources describe it as looking like an immensely complex live circuit board or like pieces of brightly colored glass intricately fused together on a single, completely flat plane.
That imagery of a live circuit board makes so much sense when you look at the mechanics of it. The veins of the leaf become what the source describes as these neon highways.
Yes, the neon highways.
And because everything is flat, you can see all the traffic simultaneously. You have water rushing down the highway in one direction and glucose just rushing back in the exact opposite direction.
It's a completely visible economy of energy.
Yeah, and the chloroplasts, the biological engines driving photosynthesis, they aren't just static green blobs anymore. They are full-on quantum factories.
Working at maximum capacity.
Right. You can watch them pulling in carbon dioxide and water, and as they synthesize food, they violently emit these tiny, brilliant sparks of green and gold energy across the flat plane.
Because what you are actually witnessing is the visualization of chemical reactions happening in real time, just translated by the microscope into visible light and lateral energy transfers.
Okay, but I need to stop and just work through the logic of this for a second.
Sure, go for it.
Because we just established that time slows down when space gets huge and complex.
Right.
But now we are inside the leaf, and you're telling me there is absolutely no depth no z-axis at all, and time feels like it's stretching out into this massive frozen epoch.
Exactly.
So if we are stuck on a flat plane and time is essentially frozen, how does anything actually happen? Like if I can't measure time by watching an object move through three-dimensional space, how does time even function here?
That is the core puzzle of this specific layer of reality. And it's a great question. At this scale, you really have to abandon the idea of a clock entirely.
No clocks.
No clocks. Time is no longer measured by physical movement through space, like, the ticking hands of a watch or a ball rolling down a hill.
So what measures it then?
In this QD cellular environment, time is measured by the sheer density of information and the speed of energy transfer.
Okay, so wait. It's not about how far something moves, it's about the sheer volume of data being processed.
Exactly.
Kind of like a computer processor. I mean, the microchip itself isn't physically moving across the room, but it's experiencing millions of events internally every microsecond just through data transfer.
That is a perfect mechanical analogy. The leaf cells are communicating constantly, just firing data back and forth. Even if you conceptually turned off the external light from the sun, the reality inside the leaf doesn't go dark.
It stays lit up.
Yeah, the cells glow with their own intrinsic light as a byproduct of this massive data exchange. It is described in the sources as a conscious, rhythmic dance of energy.
A conscious dance.
The sheer volume of chemical signals being swapped laterally across that flat plane is staggering. And those airborne microbes floating around.
Oh, right. What happens to them?
Because time is now measured strictly by the rhythm of this energy transfer, they appear as these glowing spaceships slowly drifting past, leaving these beautiful, lingering trails of light behind them.
That's incredible.
Time has literally become the rhythm of energy rather than a measurement of distance.
It is a complete paradigm shift. Time as bandwidth instead of a stopwatch. Okay, so we've gone from the giant, terrifying bug world to this flat, glowing neon circuit board.
And now we go even deeper.
Now we are engaging the ultimate zoom. We are swapping to the quantum microscope to view the absolute limit of physical reality, the atomic level.
This is where things get truly counterintuitive. To understand this level, we have to entirely shatter the traditional textbook image of an atom.
Right, what we all learned in high school.
Exactly. We are all taught the solar system model.
Yeah.
You picture a solid nucleus in the center with spherical electrons orbiting around it in neat little rings.
Well, like tiny planets.
Right. But at this final fundamental boundary, the source's thought experiment reveals something completely different. Atoms aren't spheres.
They aren't.
No. They are just flat black dots.
Wait, just flat black dots. No planetary orbits, no little spheres spinning around, just dots.
Yes, just dots. But there is a crucial mechanical rule here that the sources emphasize. These dots have finite length and width.
Okay, but why does the distinction of having length and width matter so much if they are just, flat dots anyway?
It matters entirely because of the chaotic alternative.
What do you mean?
If a fundamental building block only had length, but absolutely no width at all, it would be an infinite line. It would have no boundaries whatsoever.
Oh, I see.
Yeah, it would just stretch on forever, slicing through the universe, tangling with everything else, and creating this uncontainable chaos. It could never form an actual shape.
Because it never ends.
Exactly.
Yeah.
But because these dots have finite boundaries, specific length and width, they're contained. Those boundaries are literally what allow the universe to have physical shapes.
Okay, that makes sense.
And millions and billions of these finite, flat, black dots packed together to form what the source calls a cosmic pixel matrix.
A cosmic pixel matrix. Meaning, if I pointed this quantum microscope at my own hand, I wouldn't see skin or blood or even cells anymore.
No, none of that.
I'd literally just be looking at a densely packed galaxy of these black dots.
That's exactly what you'd see.
And that immediately creates a massive illusion of separation, doesn't it? I mean, if I look closely at a digital billboard on the side of the highway from a distance, I see a distinct picture, like a car against a blue sky.
Right, you see the full image.
But if I press my nose directly against the screen, the picture completely disappears. I can't tell where the bumper of the car ends and the sky begins because everything is just made of the exact same little LED pixels.
That is exactly what happens at the quantum boundary. At this level, there is no physical division between you and the environment.
So my boundaries just dissolve.
Completely. The dots at the very edge of your physical finger blend seamlessly into the dots that make up the oxygen in the air around you. You are a continuous, uninterrupted part of the matrix.
Okay, but hang on. If every single atom is just an identical flat black dot, how do we get the incredible variety of the universe?
Good question.
Like, how does a pile of identical dots create gold or carbon or the tissue of a human heart? Don't the building blocks have to be inherently different from each other to build different things?
You'd think so.
Hmm.
But visually, at this theoretical limit, they look absolutely identical. The mechanics that create different elements, what makes gold heavy and shiny, while oxygen is a breathable gas, they do not come from the visual shape of the dot.
So where does the difference come from?
The difference lies entirely in two factors: density and vibration speed.
Okay, so it's basically about how tightly the dots are packed together and how frantically they are buzzing in place.
Precisely. Think of it like sound waves. The air itself doesn't change, but the frequency of the vibration creates completely different pitches and notes.
Oh, wow, yeah.
Here, the frequency of the dot's vibration is what dictates the element. And because of this constant frantic vibration, it is physically impossible to isolate a single atom to study it.
You can't just pluck one out.
No, because if you try to focus your eye on one specific black dot, it constantly moves, vibrates, and just blurs right into the dot next to it.
Like it's all just shifting.
It's like staring into a rushing, chaotic river
Uh-huh.
and trying to track one single distinct molecule of water. You simply can't do it. Reality at this level is entirely fluid.
So we are essentially staring at a vibrating ocean of flat black dots.
Basically, yes.
But, that brings up a glaring visual contradiction for me.
What's that?
If the dots are black, how are we even seeing them? I mean, to see a black dot, there has to be something behind it that isn't black. A canvas, right?
Ah, yes. Contrast.
Yeah, there has to be contrast, or the whole picture just vanishes into darkness.
Well, you've just logically deduced the pathway to the absolute void.
The absolute void.
Yeah, the source material makes this exact logical leap. We can only perceive these black dots because they're silhouetted against a contrasting background.
Right.
If you remove that contrast, like if the background was also entirely black, we would hit a state of supreme nothingness known as the absolute void.
That sounds intense.
It is.
Yeah.
Because without contrast, there is no shape, no form, no transferable data at all. The very concept of an observer and a thing being observed would merge entirely into complete, suffocating darkness.
Wow.
Reality, as a separate perceivable concept, would literally cease to exist.
Okay, so if the absolute void is what happens when the lights go out, what is keeping the lights on? What exactly is the white space between these black dots that provides the contrast so we can see reality?
That background, Candace, is the quantum field. And it is glowing with what physicists call zero-point energy.
Zero-point energy, I've heard that term.
It's the fundamental, lowest possible energy state of a quantum mechanical system. It means that even in a complete vacuum, even if you stripped away every single atom, the space itself isn't empty.
It still has energy.
Yes, it still contains a baseline underlying energetic hum. But the source provides a fascinating physical explanation for what that glow actually looks like through our quantum microscope.
What does it look like?
It is described as the residual photon echo.
Okay, let's break down the mechanics of a residual photon echo, because a photon is a particle of light, right?
Correct.
And residual means leftover. So are we looking at the echoes of trapped leftover light?
You're right on the money. Think
Yeah.
about the journey of sunlight. It travels millions of miles through the 3D world, hits the leaf, passes down through that 2D cellular layer we talked about,
Right.
and finally reaches this fundamental quantum basement. But that light energy doesn't just vanish into nothingness when it gets there. It gets trapped.
Trapped, like it can't get out.
Exactly. The photons of light are physically bouncing between these densely packed, frantically vibrating black dots.
Oh, wow.
Imagine a chaotic pinball machine, where the black dots are the bumpers and the light is the pinball, just endlessly ricocheting between them.
That is incredible. So the space between atoms isn't empty space at all. It's literally a cage made of trapped light.
Yes, and because this light has been violently bouncing around, just colliding and interacting at the quantum level for so long, it has actually lost its distinct wavelengths,
Wait, meaning what?
meaning it has been stripped of its colors. So to our microscope, this trapped, ricocheting energy simply looks like a pale, colorless white mist glowing relentlessly behind the black dots.
That's the residual photon echo.
That mist is the echo, yes.
The idea that trapped, colorless sunlight is the actual canvas holding the shape of the universe together is just, it's incredible. But, it brings us to a really common, slightly controversial question.
I think I know where you're going with it.
Probably, because if everything is this deeply connected, like, if there is no real separation between my dots and the air's dots, and we are all just vibrating on this glowing white field of trapped light, what role does the observer play?
Ah, the observer effect.
Yeah, people always talk about the observer effect in quantum physics. If I am seamlessly wired into this matrix, can I just, use my thoughts to make the black dots across the room move faster?
Right, the telepathy question.
Exactly. Is this the scientific basis for telepathy?
It is an incredibly tempting leap to make, especially when the visual imagery feels so completely interconnected. But, and the sources are clear on this, we have to ground this tightly in physical mechanics.
So that's a no.
That is a hard no. You cannot move an outside atom simply by wishing it to move across the void.
So I can't just think my coffee cup into my hand?
You cannot. There is no magical telepathic bridge where your mind just bypasses physical space.
Bummer.
I know, right? However, your connection to the matrix is still profoundly real. We just have to ask, what actually is a thought?
Okay. What is a thought in this context?
Your thought is not some ghost hovering outside the system. Your thought is atomic movement.
Oh, I see.
It is the physical electrochemical dancing of atoms and electrons within the neural pathways of your biological brain. Your thought is a highly specific physical event happening inside the matrix itself.
So my thought is literally just a localized pattern of dots vibrating inside my skull.
Exactly. It's a physical action. But to move a dot outside of your skull, say, an atom in that leaf we were observing earlier, your thought has to translate into a physical chain of action.
Like a domino effect.
Right. Your brain fires an electrochemical signal. That signal, which is a wave of atomic vibration, travels down the nervous system in your arm.
Okay.
That triggers the muscles in your finger to contract. Your finger physically presses against the leaf. That physical touch transfers kinetic and thermal energy to the leaf, which then physically forces the black dots inside the leaf to vibrate at a higher speed.
Wow.
So you absolutely have the power to move the universe, but you are required to do it through a physical chain of energy transfer, not through some invisible telepathic wish.
That is deeply satisfying. It strips away the magical thinking, but it still proves we are entirely wired into the hardware of reality.
Exactly.
We aren't just sitting in the audience observing the universe. We are the universe observing itself through this massive physical chain reaction.
Beautifully said. And arriving at that realization really brings us to the grand synthesis of this entire deep dive.
The big takeaway.
Right. The source material builds all of these layers toward a massive philosophical breakthrough, a concept we can basically call the inverse relativity of time.
The inverse relativity of time. Okay, let's spend some time unpacking exactly how that paradox works.
Sure. Think about the whole trajectory of our journey today. We started at the standard human scale.
Yeah.
We zoomed in on the insect world, and your perception of time slowed down because the space expanded.
Because of the massive z-axis.
Exactly. Then we pushed deeper into the 2D cellular leaf, and time slowed down even more, transforming into this sluggish rhythm of data transfer. And finally, we hit the quantum atomic level.
Where time for the observer has essentially ground to a complete halt.
Exactly. As you, the observer, zoom deeper and deeper into the fundamental fabric of reality, your perceived time slows down until you reach a state of complete, absolute stillness.
Like you're completely frozen.
You become a frozen, eternal observer just standing outside of time. But the paradox lies in what is actually happening to the object you are observing.
Right, the dots.
While you read absolute stillness, those flat black atomic dots reach maximum uncontrollable speed. They are vibrating so infinitely fast in such a chaotic dynamic blur that they can't even be pinned down as individual shapes.
So absolute stillness in the observer mirrors absolute dynamism in the observed.
Exactly.
As the person looking through the microscope gets quieter and more frozen, the fundamental building blocks of the universe reveal themselves to be infinitely fast and chaotic.
It entirely recontextualizes how a person should view their own existence and, well, their own biology.
It really does. It flips everything upside down. And I want to leave you, listening to this deep dive, with a direct reflection to chew on as you go about the rest of your day.
It's a great thought experiment.
It is. I want you to think about your standard, everyday, three-dimensional human life. Think about the stress you constantly carry around.
We all have it.
Yeah, you're rushing to work, trying to meet a deadline, constantly checking your phone, feeling this intense, heavy pressure that time is running out. You exist in this frantic, exhausting state.
Almost constantly.
But yet, hiding inside you at this exact second, at the very foundational level of your biology, your core components have absolutely no concept of a clock.
None at all.
The very fabric making up your stressed out, rushing body is actually existing in a state of absolute eternal stillness. And simultaneously, those identical components are performing an infinitely fast, eternal cosmic dance on a glowing field of trapped light.
It's quite a paradox to hold in your mind.
It is. So the next time you feel completely overwhelmed by the speed, the pressure, and the stress of this 3D world, ask yourself, which layer of your reality are you going to tune into?